it will bring up this little screen. Can we be quiet? It'll bring up a little screen that says enter time increment. The bigger the number you put in there, the faster it'll run, and the less accurate it'll be. The smaller, if you want it to be really accurate, you can put a small number in there. It's just a simulation, okay? A C simulation. So I'm going to put in, I think 20 works really nice, or maybe 30, I don't know. Okay? And then there we are. We're basically going to fall into a black hole and like get sucked away. So I'm going to hit enter again. There we are. Now if I hit the right arrow, you can see, and I'll just turn off the lights because you really can't see with like that. There we are. And again, all I did, basically the coin is set to basically roll straight down into the hole. You know those little things that collect the coins, and the coins roll around and around and around like the little gravity well things, right? Basically the coin is just rolling straight toward the hole, and so if you don't deflect it off to the side with one of the arrow keys, it's not going to go around in a circle, but if you do, it does, right? So just deflect it this way or that way, and you're good, right? So I'll just hit enter again, and this time I'm going to hit the up arrow a few times. Don't hold it down or it'll repeat, and then just like, my hands are free, it is now coasting, right? There it is. Let it roll down in a little bit to pick up speed, and then just send it off to the side, right? Okay, so that's the trick. The first thing says, practice until you can get into a fairly circular orbit, and that's good enough. Doesn't have to be perfect. It's obviously not a perfect circle because the planet would be at the center of that circle, right? So let's hit this again. Now let's totally cheat. I'm typing the letter O, which immediately beams us into this little spot right here, gives us an upward velocity that is exactly equal to the orbital velocity at that distance, and around we go, right? So then it says, start over, type the O key, put yourself in a perfect circular orbit. Let the spaceship complete one revolution, then slow the ship down abruptly by hitting the R key. R is retro rockets, not like retro as in like style, but retro as in like slowing you down, right? So I'm going to hit the R key 5 times. 1, 2, 3, 4, 5. Okay? And what happens is, of course, I fall down into that thing, right? It's like I get on lower, which actually, what happens to my speed? When I slow down, I actually speed myself up because I fall closer to the star, which speeds me up, which flings me out, which slows me down, which makes me fall, which speeds me up, which makes me fling out, which slows me down, etc., over and over again. This is how you draw an ellipse, apparently one way, right? Okay? And so there we are. So what we want is a picture of this. This looks like something, right? So we got a little diagram of that. Draw a picture of the new orbit in relationship to the old, right? And then, of course, I think last time we sped up and got back to the old one, right? So where do we speed up to get back? It's like right there, right? 5 times right here. Who's your physics teacher? The other time was better, wasn't it? Right? Which orbit is faster? So then it says compare a close orbit to a low orbit, right? So let's go. Okay, let's get down there, and then let's go. I'm going to make a low orbit, so to slow myself down and bring that orbit in, I'm just going to slow down right here. There we go. There's a low orbit, a high orbit, right? Okay. It's harder to do that, right? There's like, it's not quite as tangent. Okay. But there it is. So here's a low orbit. How does when the coin is closer to the thing, how does its speed compare to when it's farther away, right? That's the question. And then it says, get in an elliptical orbit and observe your motion. Well, how do you do that? Let's see. I'm just going to start over again, and I'm going to deflect myself one way. Let's see what happens. Is that too close? Oh. Yeah, maybe I'm gone. Maybe I'm not, though. Let's see. I should come back. The laws of physics say I should. The laws of computer simulations say that it might have... there we go. I should be actually retracing exactly my orbital trajectory. So I'm going to hit over. What it's doing here is it's actually making a bunch of numerical errors close to here, right? Because it's going so darn fast. So I'm going to go start over. I'm going to hit the up arrow twice. That ought to still be fairly elliptical. There we go. A little farther from the star.
There we go.
Right. I just don't like seeing my computer simulation give bad numbers. And even then, it's still not quite retracing its path, but it's pretty close, right? Right. So the question here is label the regions where you're going the fastest and slowest. Well, duh, right? And then conservation of energy says it's got the same total energy, so it's got potential and kinetic. Where does it have more kinetic? Where does it have more potential? I think you can answer that, right? Okay. And then blah, 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 right? That's the Orbit Lab. So you're going to do those drawings, answer those short questions, every man, woman, and child, and then you can turn that in. That's 25 points. Okay. Now, what else there is, let me just show you what else there is, because this is just too much fun. I couldn't just write one program, so I wrote another one. Okay, this is called New Orbit. And this one's kind of fun because you can Strike the any key. I'm going to make my time increment, I'm going to try 30. How about 25, because I'm just not that good. Okay, there we are. And this is like, you know, the targeting center of a missile or something like that. Now this is actually, I'm in orbit, and what I want to do is I want to get into orbit into this, right? So I want to get myself inside the red ring, or I want to get myself out there. So this is like orbit changing. And they do this to change orbits. They've got to do maneuvers like this. So they'll fire the rocket engine and change their orbit and then change it. So to get myself down in that middle one, gee, I don't know. Let's see. Let's try 8 times. That's not nearly enough, right? There we go. So I'm going to bring it down in. Let's try 3 more times. And I'm firing it over here. So let's go. Is that going to do it? Did it 4 times there. Well, that's so close. How about 2 more times? So now I got part of the orbit in the right place, right? So how do I bring this side into here? I got to do it here. I got to fire there. Isn't that the weirdest thing? To affect the orbit on one side, you got to fire it on the opposite side, right? But somebody obviously has figured this out, right? So how many R's do you think I should hit? 20. How about 6? I'll try 6. 6 sounds like a good one. I think I could do 6. Here we go. Oh, that's not enough. How about 3 more?
4 more.
4 might have been the right answer. 1 more? Nope.
2 more. Yeah.
There you go. Technically, I think we've achieved our goal, right? Now let me show you. Let's suppose you don't like mashing keys. I'm just mashing the R key. So let me show you this. I'm very proud of this, right? Okay, I'm going to hit enter. We start over again. And then there's a program fire. So P is program fire. And these units are not keystrokes. They're a finer increment here. So I go program fire, right? And it says enter fire amount followed by R or S, right? So you just type in a number. So I'm going to try 600. And I'm going to go R. When I hit R, it retros 600. Whatever that means. I don't know what it means. 600 wasn't nearly enough, was it?
Like 600 what?
600 units of thrust, whatever, right? You know. So this would be, if you're actually in an orbit or something, this would be 600 seconds of fire time or something like that, right? And this would be happening. So let's do another. How much more do we need? That was 600. So no, because we need to. 600 brought it this far.
We need like 12. We need like.
That's at least 100. What do you think? 150? Should we say
175?
175? Okay. Program fire 175, and now I can pick the exact time to fire it. I'm going to fire it right there. 175 wasn't enough, was it? 400? Not now. So how about 125? 125? 225?
5.
I ignored you before, so I'm going to go with you. Here we go. R right now.
That's a good call.
225 wasn't even enough. Look at that.
I told you.
Okay, how much more? Just a little bit more, huh? 50? 75? Okay, program 75. 75? It is. Okay, here we go. Retro, going right now. There we go. Yeah, there we are. Okay, so now we need, how much do we need to bring this side in?
We're going to need a good, like, 500.
1,000?
Yeah.
Let's go for 1,000. What the hell? Feels good.
Nice. I like your stuff.
1001.
Don't do it.
Okay. Okay, are we ready for this? Retro right now. Ooh. Should have been like 1,007 or something like that, right?
Yeah.
Okay, program fire. What do we want? 30? Okay, here we go. Right now. This switch.
50.
I didn't do anything.
Do 100. 58.5. Do 100.
100. Okay, here we go. Ready? Right now.
Yeah.
That's like right on the line, baby. There you have it. So obviously, I suck at this, but you could do it. Obviously, the number of things to get from one orbit to another is 2 firings, correct? So you can figure out whatever it is to get to the lower one. To get to the upper one, do you speed up or slow down?
The upper one, you got to slow down.
No, see, there we go, right? You have to speed yourself up because that flings you out, right? Okay. Or you're right, and then of course the crazy thing is that when you speed up, you'll move to an outer orbit where you actually slow down, right? So slowing down in an orbit makes you fall to a lower orbit where you speed up, and speeding up makes you rise to a higher